Let's look at something called solving exponential equations. And I'm going to break this lesson into about 3 parts. Why? They're not really related. That's why. And in the textbook, they're all put under 5.3. So let's have fun with this. This is cool. Watch this. This is 2 to the power x. And I don't particularly like the way this particular program writes it. So I'm going to write it just underneath it. 2 to the power of x, there it is, equals to 1024. And you have to somehow solve for x. Well, interesting thing is look at this base. This usually tells you that this 1024 here is some sort of 2 to the power of something. And that's when you pull out your calculator. Get your little calculator going here and try to figure out something that 2 to the power of something, okay, gives you 1024. So just start trying a whole bunch of different things. Try 5 and see what you get. No, that's 32. That's way too small. So we've got to go a little bit bigger than that. Let's try 8. Oh, we're getting closer at 256. Let's try 9. 512. I bet you can figure it out already. 2 to the power of 10 actually gives you 1024. Great. So we know that this mess could actually be written as 2 to the power of 10. Now, let's go back to the original equation. The original equation was 2 to the x. And now look what it equals to. It equals 2 to the power of 10. Now let me show you something that's incredibly powerful. Now that these two bases are the same, you can actually cancel them. And look what you get. You have x equals to 10. Aha. There's your answer. Isn't that pretty? So let's take a look at the very next question here. Let me erase a little bit off here so that you can actually see it. Look what happens when you have something like this guy here, right? You have 2 to the power of x again, but now that's 1 over 1024. But wait a second. You know that 1024 already equals to 2 to the 10. So isn't this like saying 2 to the x equals to 1 over 2 to the 10? But wait a second. 2 to the 10 in a denominator, you know from grade 9 that you can actually make this guy right here into 2 to the negative 10. Because remember, the negative just means 1 over. Okay, so let's go back and look at the original problem now. Okay, the original problem looks like this, but now here's what this looks like. Aha! 2 to the negative 10. And guess what? The 2's can cancel. X equals to negative 10. Watch again with a different base other than 2. This becomes really, really kind of fun. You got 4 to the power of x. You know that this is going to be some sort of factor of 4. You have no idea what it is, but you know because it's in the denominator, it's going to be to the negative. All right, let's pull out our calculator. Okay, and try to figure out something for 256. Let's go 4 to the power of 4 and let's see what it is. Oh, it was a fluke, but there it is. So you know it's 4 to the power of 4 gives you 256. 4 to the power of negative 4 gives you this guy right here. So guess what? The 4's cancel. X equals to negative 4. Just the tops equal then, right? Look at this one. This one's a bit of a challenge now. This is 27 to the x and 9 to the 2x minus 1. What do you do now? You got x's on both sides. Well, first thing is you don't fret. This is actually pretty easy. You should realize that 27 can be written as 3 to the power of 3. Don't believe me? Pull out the calculator. Let's see. 3 to the power of 3 works out to be 27. So now you're reducing it down to a real pretty root. Now, or a pretty base. Look at the 9. Same thing. 9 is 3 to the power of 2, but you have this 2x minus 1 here. Well, check it out. What did I say earlier? Your bases are the same, so you can cancel them. Check this out. You've got 3 equals to 2 times 2x minus 1, and this now becomes real simple algebra. Distribute this in there. Let's bring it up here so we have more room. 3 equals to, well, 2 times 2x is 4x. Bring the 2 over to here, giving you minus 2. And all you have to do now is just add 2 to both sides. There we go. That cancels, leaving 4x equals to 5. Divide by 4, and sure enough, x equals, oops, that's supposed to be 4. X equals to 5 over 4, and there's your answer. Real pretty, really easy. Let's make it a little bit more complicated by throwing a root in there now. So, okay, there's your 2 to the power x. That's fine. Look at this 4. Isn't that 2 squared? Now, how do you do this guy? Do you remember last year I taught you flower power. Remember? Flower power, there's the roots. Right, so you want to put this root 2 as an exponent, but you have to remember, when you talk about square root, that's the 2, that's the root. So this is 1 over 2. Why is it 1 over 2? Because this is 2 to the power of 1. So 2 to the power of 1, power goes on top, root goes on the bottom, just like the flower power and the root. Right, okay. So in other words, you can write this as, this guy now could be written as 2 to the 1/2. Now check this out. Like bases, multiplication means what can you do to the powers? Yeah, I know you're saying it right now, but don't forget, you're talking to a recording, right? Anyways, 2 to the 2 plus 1/2 gives you actually 2 to the x equals 2 to the 2.5, or 2.5. Get rid of the 2's, and guess what x equals to? X equals to 2.5. So now let's make it even a little bit more complicated. Look at this one. You're still dealing with 2 to the x, but check this guy out now. Uh-oh, look at this. 8 is 2 cubed, and look at this. Don't forget your flower power. Yeah, there's your flower, right? There's your root. All right, so the root here is cubed root. The power here is 1. So what's 1 over 3? So this is times 2 to the 1/3. Multiplication means you add these two things. So this is 2 to the x equal 2 to the 3 and 1/3. The 2's cancel, giving you x equals to 3 and 1/3. There's your answer. 3 and 1/3. Now, look at number 7. Here's the toughest one of them all, and let's see if we can figure this out. Cool thing is you should realize that this has got a 5 in it. So always look for some sort of root of 5. So this is 125. So let's see. What is the square root of 125? Well, I don't know, but I do know that that's 5 cubed if you think about it, right? So I want the square root of 5 cubed all to the power of 2x minus 1, or 2x plus 1. Well, that's a mess. Let's take a look at this first. Let's bring it over here. The square root of 5 cubed. So, remembering flower power, there's the flower, there's the root. The root is 2, the power is 3. So isn't this the same as saying 5 to the 3 over 2? Why not? Okay? Times that by 2x plus 1 equals to, take a look, 625. Now wait a second. 625, I know. 625, isn't that 5 to the power of 4? Let's check. I can't remember. Let's go back to here. 5 to the power of 4, I think, is 625. I am right. Look at that. Excellent. Okay, so I know that this means that this is 5 to the power of 4, and it's going to be cubed rooted. Okay, flower power again means that this is 5 to the 4/3. Okay, so 5 to the 4/3. Are you with me? Holy smokes. Now look at this. This has to be multiplied by this guy. Just distribute it in. Okay, here we go. So this is 5. Now, you got 3 over 2 times 2x, which gives you 3x. You got 3 over 2 times 1 plus 3 over 2 equals to 5 to the 4/3. And look at that. Isn't that pretty? The 5's are the same, so they cancel out. Great. Give me 3x plus 3 over 2 equals to 4/3. Now, let's start subtracting this and see what we get. So subtract 3 over 2 from both sides. Okay, that cancels, leaving you 3x equals to 4/3 minus 3 over 2. 4/3 minus 3 over 2 is what? Well, multiply that by 2, giving you 8 over 6. Multiply that by 3, giving you minus 9 over 6. So guess what you get? You get 1/6. Beautiful. So you got 3x equaling to negative 1/6. Now, divide each side by 3, divide each side by 3, and what do you get? Well, don't forget, this is the same as timesing it by 1/3. Holy smokes, this is a lesson in fractions. X equals to negative 1 over 18. And there's your answer.